Hey, good morning, good afternoon, everyone. This is Bill Brab with AST Environmental, located in Midway, Kentucky. Going to talk with you today about a fiscally conscious DNAPL remediation project where a legacy liability to the client was taken to manage closure earlier this year as part of our ongoing webinar series. Again, my name is Bill Brab, Senior Remediation Geologist here at AST, based in Midway, Kentucky, on the in-situ remediation team. So a little bit of background about the facility that we're going to talk about today is it's a former chemical plant located in Western Kentucky. Confidential client and consultant here, so we're going to keep the location as detailed as it's shown right here. But we can talk about it in general terms and get some good information to you from what we can share today. Multiple solvents were released and located at the facility throughout the history of the use at the property, including methylisobutyl carbinol, abbreviated as MIBC here, TCE, peroxide, acetone, ethanol, and some diesel fuel. So when AST became involved in early 2011, the initial remedial objectives were to refine the existing conceptual site model to more accurately and define the total contaminant mass present within soil and groundwater at the facility. Because of the scale of the site and being on a fixed budget, this was to be implemented as a multi-year remediation plan based upon what was achievable, feasible, and affordable at the time. As part of that, also, the objective was to achieve significant reductions in contaminant mass and to work towards ultimately a managed closure of the facility. And the biggest hurdle or the biggest goal that needed to be achieved was to stop CVOCs from migrating onto offsite residential properties from the industrial property where the releases had occurred. So just a snapshot of all the phases that have happened at the facility over the history of this managed and phased approach across the entire project scheme was to show all of these pieces and parts individually. And so we can see here that initially with the bullets in red, these were original projected phases based upon the feasibility and availability of the chemical treatments and access that we had at the facility to manage the contaminant stream at this facility. A remedial design characterization, or RDC for short, essentially a data gap elimination exercise to get analytical data for quantifying mass, occurred over the course of 2011-2012 initially for the initial characterization, with a subsequent investigation in 2020 as we approached closing out the site, and a small soil gas survey that was performed in 2012 for vapor mitigation issues located adjacent to the property. The initial phase of remediation at the facility was, again, talking about that preventing of CVOCs from migrating off-site onto the residential properties, and this consisted of a off-site BOS 100 permeable reactive barrier installation that occurred in late 2013 and early 2014. As part of that phase as well, there was a shallow soil blending with ISCO to mitigate unsaturated soil impacts adjacent to one of the residences. And then a series of CAT 100 injections located on and off-site that were steered more towards actually source removal and expediting getting the site to closure within a more reasonable time frame as the technology improved. And we'll talk about both technologies and that improvement a little further in the presentation here. And one of the optional phases that was proposed, but it has not been implemented and probably will not be, was a larger unsaturated soil blending using in-situ chemical oxidation within the source area of the facility. So just looking at the call it 8 to 9 year time frame of investigation and remediation of the facility shown here. So a little bit of history for the site. There were multiple releases at the facility over the lifespan of the property usage. With the environmental boom occurring early in the late 90s or late 80s, early 90s, subsurface investigation began in 1991 and detected the presence of CVOCs, PCE being the highest concentration and most widespread across the facility. And during that time frame of early investigation and interim corrective action, combination of ex situ and in situ methods were selected and utilized at the facility. So getting back to the time frame at which the project came to AST's front doorstep, and my involvement in the project, looking at the source area located here in the general area of this former shed and monitoring well PDC 15, source impacts, ppm level, PCE, TCE, triple digit ppm of cis and double digit ppm levels of vinyl chloride. Looking down gradient for concentrations this high, it's not really all that far. It's only about 200 to 300 feet. It has not migrated very far in this length of time since these solvents were discharged into the environment. But we're seeing similar concentrations of PCE and groundwater with less concentrations of degradation byproducts that come from the breakdown of that. So relatively intact contaminant stream. So looking at the initial phases of investigation, or the RDC as I defined earlier, conducted in late 2011 through 2013. All of these locations, AST/SB, these are all sole borings that were installed at the facility. 44 of those borings were installed to characterize the vertical profile of the soil contaminant mass present in the facility. At each location, a nested well cluster was installed to assess the potential for a vertical groundwater gradient concentration that we were seeing versus having long well screens of the full monitoring well network that were present. And as part of that, also getting a snapshot sampling event of that full monitoring well network as well to have comparison to. These red points here were just kind of additional points after the initial. So again, we talk about these multiple years here or multiple events. This was to get better definition on this western side to ensure that we had, in fact, migrated out of the contamination and were not needing to go further off site. So looking at the findings from the RDC, to give some quantification as to the value of this investigation and to provide expectations and management of timing for the client involved in the responsible party. Looking at the source groundwater conditions, we see quite a bit more significant presence of PCE compared to what we saw during the baseline conceptual site model prior to the investigation. If you recall, in the source area groundwater, we did see double-digit ppb, but during the sampling event, we did find quite a bit more significant mass of PCE located in the groundwater. Similar TCE, more than double concentration of the cis, similar vinyl chloride, and the presence of carbon tetrachloride was also noted, which was historically not seen during the previous investigations at the facility. In addition to that, a non-regulated compound of MIBK, which is methylisobutyl ketone. This is the degradation product of the MIBC that was released historically, as we had talked about on a previous slide. Looking at the distal plume or the dissolved plume down gradient, we can also see that there's a similar concentration of PC and daughter products that we had seen historically. This is moving, again, when we talk about dissolved plume, we're talking about down gradient on these residential properties, whereas our source groundwater is up here on site within the property boundaries of the facility. We do see a little bit of that MIBK as well off site in this case here, because we were looking for it as part of the degradation pathway. One of the pieces of information that was not historically available was the amount of mass present in saturated soil. Saturated soils beginning at about 20 feet and extending to about 40 feet below grade. And I'll talk about the geology below at the bottom part of this slide. But we see significant saturated concentrations of PCE and respective byproducts, as well as carbon tet and degradation products related to that compound. 2,700 ppm of PCE in the source is quite significant, obviously. The geology is from about 0 to 40 foot below grade, a low permeability silt and clay, on the order of 10 to the minus 7 centimeters per second. And below that, you've got a 40-foot kind of divide. Below the 40-foot divide, you have a poorly sorted, fine-grained sand artesian groundwater aquifer. And so the bulk of the mass is in this low permeable clay. Impacts in the sand are minimal to non-existent. And we believe that's hydraulically controlled based upon this artesian condition of the aquifer below that boundary. So I had the slide earlier with the bullets showing all the phased events. This is a graphical representation as of fall 2022, showing all the phases completed at the facility. Busy slide with all of the different colors and things going here, but we've got some definition here to help you out just a little bit. So phase 1, BOS 100 PRB and shallow ISCO blending is this area of green dots with these kind of amoeba looking things in the middle here. That's the injection and the soil blending occurring in 2013 and 2014. A little bit of time elapses following the barrier installation. Installation of a CAT 100 source pilot test. Again, I'll talk about these technologies here in just a minute and the methodology for why this was done. So we have this little pilot test within the source area done in 2016. An extension of the PRB utilizing the same CAT 100 technology in 2018. Going back into the source with a more aggressive treatment and expansion of the source treatment in 2019 with CAT 100, going after another section of the source in 2020 with CAT 100, and then doing the final round of treatment within the source, one being in the main source, two being a secondary source identified during the 2020 RDC, using CAT 100 again here on both of these injections. So I've talked about the technology. So for those of you who don't know, what are these things? So the phase 1 selected technology was BOS 100, which is the full name is Trap and Treat BOS 100. This is a product by Remediation Products Incorporated that is one of the original activated carbon technologies utilizing granular activated carbon. And this material is impregnated with metallic iron, not GAC with ZVI floating around in it. This is actually iron bonded to the activated carbon surface in a manufacturing process. And this is strictly an abiotic beta pathway elimination chemistry. So we're looking strictly at a chemical process here. And it's primarily used in the treatment of chlorinated solvents. Also, as part of that phase 1 selected technology was soil blending using activated persulfate. This was a limited small excavation from 0 to 4 feet. We can see that here, looking at that chemical oxidation being applied here in the offsite area. That's actually defined for you right here by this kind of orange dashed rectangle that we see along the former railroad spur. Shallow excavation, piano keyed in with an excavator and using super sacks of that material to blend it in and neutralize any contaminant located within the 0 to 4 foot horizon of the unsaturated soil. Here we see a typical geoprobe. This is the fence line here. So if we're standing kind of up here at the top of this screenshot image here, looking down the page, that fence line runs right here and turns. That's this kind of line with circles here. And then that roadway, that alleyway here that goes from right to left, as I'm showing with my pointer, that is this alleyway right here. So that's showing kind of that geoprobe going down one of these rows along this permeable reactive barrier that's being installed. So looking at the results, again, there was a bit of a time gap in between implementation of the phase one technologies and seeing how things shaped up and went for moving into something else. And so the 180 day post injection results in the down gradient dissolved phase plume showed some very high success rates in reducing CVOC contamination in dissolved phase groundwater at the very distal end of the plume and mitigating those impacts and risks to the offsite residential properties. So this information was used and monitored for several years before the regulatory body and the consulting firm and client that we ultimately work for decided that they wanted to be a bit more aggressive with this technology and go into the source and try and get the time to clean up to be expedited in a much sooner time frame. And so that gets into the second technology that was deployed out here as we move into the later phases and years of the project. And so as time went along, innovations and improvements in the technology for implementation came about a product called CAT 100. And so this is essentially taking the base activated carbon impregnated with metallic iron platform of BOS 100 and making an improvement upon it to preserve the finite amount of iron present within that material and allow further degradation to occur without having to provide maintenance and reinstallation of additional carbon platform. And so that BOS 100 is mixed with a complex carbohydrate with a blend of microorganisms. One set is specifically designed to degrade the contaminants of concern. The second set is to break down those complex carbohydrates into simple sugars and provide essentially free radical electrons and energy for the existing microcosm to be able to have free electrons shuttling across the carbon surface to the receptor sites on the iron. And what this does is it allows the carbon and the iron to work in unison to act as a full-blown catalyst and to preserve the actual metallic iron receptor sites on the carbon to where it's not degraded and not expended as part of the degradation of the CVOCs. And so this technology was developed for dealing with high concentration scenarios and the potential presence of DNAPL, where a single injection event of traditional BOS 100 could not reach the site cleanup goals in a single injection event. And so this provided a game-changing technology to the marketplace that allows for higher rates of degradation and greater rates to getting to the site closure in a more timely manner. And so skipping forward to kind of some of the performance monitoring aspects of evaluating performance at the site. So we talked about the phases a minute ago, showing the slide with how this CAT 100 technology was deployed for the remaining injection events at the facility. But during this time frame of monitoring, during all of this, we're looking at chemical monitoring as well as other lines of evidence to demonstrate removal of contaminant from the subsurface and degradation, destruction of those contaminants rather than sequestration onto the carbon. One of those being microbial diagnostics, looking at the populations within the monitoring wells and the formation in control areas versus source areas versus distal down gradient zones. And so if we look at a background zone being PDC 11 prior to any augmentation in the central parking lot of the facility, we see that the background or that the microbial population is indicative of background in the formation, and that was comprised of methane reducers. Whereas if we look at the CAT 100 treatment areas, both the source area here near PDC 15, where both this was a pilot area, as well as all that source treatment that we saw before, kind of circling in and covering this area, expanding to PDC 13 and PDC 14. So this is your source treatment, and your PDC 16 here is your kind of distal plume dissolve phase. This was actually the barrier extension zone where the CAT 100 technology was deployed. In this area here, we see something quite a bit different. We see that the dominant species of microbes was actually dehalogenating bacteria. And specifically, what we want to see in this type of scenario is DHC. But something that's very important to note as part of the CAT 100 technology is we don't actually add DHC because of its difficult nature with which to maintain and to deploy. But what we see is that by bolstering and supplying the right environment for the microcosm within this particular treatment area, that DHC population actually began to flourish and become quite dominant within this area, showing that the actual removal of CVOC mass was preferred based upon the population of microbes within this zone. So looking at the COC concentrations, now we can see actual removal of mass in the dissolved phase stream and total CVOCs in groundwater as of November 2022. And what we can see is quite profound. Looking at the shoring up of that down gradient portion of the barrier in that CAT 100 area, we're seeing 91% reduction of CVOC mass over the history of implementation since 2013 to 2022. Looking at PDC number 3, we see a greater than 99% reduction. And then getting into the source area, we see greater than 99% reduction in PDC 14, and our highest concentration monitoring well 15 with a 628 initial concentration down to 20, or a 97% reduction. So a significant reduction in mass and elimination of risk within the on-site source area, as well as the down gradient distal areas of the plume. Another line of evidence to support decisions at the site is during that RDC work done in 2020, showing resampling of soil adjacent to locations where the historical RDC occurred back in 2011. And we can see here soil samples taken from the source area near this PDC 15 well, as we've seen historically on the wells. We have soil boring 7 was initiated in 2011. And then in 2021, on one of those RDC events that occurred to better characterize and get ready for the final injection, we have SP 20-17 in 2021 noted by the orange line here. And what we have here is we have total CVOCs in ppb located on the x-axis up here, and we're looking at concentration versus depth, so depth going down the page right here. So we're basically looking down borehole in cross-sectional view. And so what we can see is as we get further down into the groundwater occurring somewhere around 20 feet, we see saturated soil conditions are significant back in 2017, with the highest concentration being well over 2 million ppb of total CVOCs in soil. And then tapering off again at that terminal boundary located at 40 feet BGS. And then that resampling boring done in 2021, showing that across the board on every sample, we do have, in fact, significant reductions and a similar geometry and curve that's mimicked by the historical samples versus the current. So again, showing removal of mass and microbial population indicative of CVOC destruction led to some good decisions moving forward into the final part of the decision making in late 2022, current time of this presentation. So some final considerations here, looking at fiscal consciousness, again, one of the components of the title of this presentation. Remedial design characterization, getting an idea of roughly a 96,000 square foot area that needed to be defined and characterized. You're looking at 3 events totaling an approximate cost of about $74,000 to be able to get that level of data, which was quite valuable to be able to manage a site that, when we look at the total cost of the project of over $1 million, being able to manage that better and plan for it is quite crucial. The ISCO soil blending event done in 2013, if I recall the date correctly, it's approximately $38,000. So another small budget item to eliminate a small risk pathway next to adjacent residents. Looking at the in-situ injections, 6 events totaling $1.02 million. And if you break that down, you're looking at roughly $170,000 per event, Or if you're looking at spacing out that budget over the course of multiple fiscal years for budget management, you're looking at about $128,000 per year over the course of the 2013 through 2020 project timeline of the implementations at the facility. So just to get into the current status of the site and final actions of the facility to wrap up the presentation here, the on-site structures of this facility were raised in spring of 2021 for future development. The city had actually purchased this property and plans to redevelop it once the site is closed. The final source treatment that I noted before was completed in September of 2021, as well as a alternate source treatment that was identified during that RDC in 2020 was completed also in the in situ in the fall of 2021 as during the number 2 bullet above. The great part about this, or the exciting part about this, is that the client, after looking at all the lines of evidence and stacking everything up with where the site is currently moving, has recommended moving the site into managed closure in this quarter of 2022 and getting the site essentially off the books for everyone and into redevelopment for essentially removing a legacy liability to an actual usable piece of property. So excellent win, great news here, and we're super excited about it. And so this concludes my presentation today. I really appreciate everyone joining me and hearing about this really interesting project and exciting technology development over time. I've noted a couple of resources here as we wind down for your consideration. AST does have an extensive website archive of our historical webinars that we put on and record. You're welcome to go to this link right here and check those out. This webinar here will be uploaded to that in the coming days after the recording becomes available. We do have questions, or if anybody has questions that they would like to address with me related to this project, any of the technologies that are involved here, or any other thing about both AST or RPI, my contact information is located here. You are more than welcome to reach out to me directly and get any additional information or dialogue as you may wish. And with that, I will pass the reins off and move on with the day. And I appreciate everybody's time. Thank you.